So my name is Nikhil and I'm from the University of Sheffield. And my actual title is Automatic Artifact. You can read the rest, this is jargon, and I prefer you not to focus on that, but the main field is brain-computer interface. What this is it's something that will let you control the outside world using your thoughts alone. And I'm not making this up, and at the last slide you'll be more convinced of this. And so first a bit about the human brain. The human brain in itself is like a whole universe within your ears, and it's amazing. And when you think or when your neurons are active, it's made up of neurons. Neurons, billions of neurons, and when they're active, they produce these electrical signals, which travel all the way up to the scalp, and you can measure it on your scalp. So you can think of these neurons as talking to each other, sometimes softly, sometimes loudly, and these echoes, you can hear it all the way in your scalp. And the basic underlying technology behind BCIs are you use these headsets called EEG headsets, and they measure these electrical activity. Sort of like microphones measuring the echoes of, if you want to use that analogy. So yeah, this is a basic block diagram. First you acquire your signals using those headsets, and then it's all the computer's job. The computer processes it and uses some clever algorithms to decode what your thought was. And these thoughts can be different things, and I'll explain that later. And so once the computer software has kind of recognized what your thought was, it will then send commands to like an outside device like a wheelchair, or to say a presentation slide to move to the next slide, and there are many applications. So what can you think about? Obviously the computer can't recognize every single one of your thoughts. That would be amazing, but right now it can't. And one specific thought that it can recognize that I worked on was called motor imagery. So this is what happens when you think about movement, not actually move, but when you think about movement, this part of your brain called the motor cortex, the neurons that are there starts to become less active, and computers can recognize that easily, the software, the algorithms. So that's one thing you can work on. It's called thinking about movement. But there's one big problem in this field is artifacts. So what these are essentially, what artifacts are like, they're like noise. So when you're thinking, the neurons produce electrical activity, and that's good, that's what you want to measure. But at the same time, when you say move your hands or blink your eyes, they also produce electrical activity that travel all the way to the scalp. And they make your data messy, and it makes it harder for the computer to decode what your thought was. And so this was what I focused on in my project, was to develop software that will automatically remove these artifacts so that the computer will find it easier to decode what your thought was. And this is a huge field in BCIs, brain-computer interfaces, removing the artifacts. Yeah, so this is my results, and results from my brain. And so what you see here is this is me blinking my eyes while moving trying to move my left hand. And so this is what you expect the left hand motor imagery to look like. Decrease in activity near the motor cortex, which is here, but the headsets that I used were quite old, and so it's not, the electrodes there were missing, so that's why you see it all the way back. And these are associated with eye blinks. When you blink your eyes, there's high electrical activity, high power in the frontal lobe, like near the eyes. So, and the computer will find it difficult to decode this bit of the thought. So I developed some artifact removal, use some signal processing techniques to automatically remove these. And after I remove and I apply the algorithm again, you see the artifacts are removed, the eye blinks are removed, and there's a clearer picture of my left hand motor imagery. And then using that, the computer will more accurately and more quickly and more effectively decode what my thought was. And a bit about, so I didn't talk much about this because it's very technical. How you get here from the raw electrical signals that you measure and how you get to this is a whole other field. It's called source localization. You can also use like machine learning techniques and stuff, but I'm not going into that. But I use source localization techniques to go from the raw signals to see where my motor imagery is in my brain. So yeah, these are just my results before artifact removal and after artifact removal. And this is my thought of moving my left hand motor imagery. Are we good for time?
Yeah.
Okay. 3 minutes, okay. So, like I said, it might be quite hard to believe. Like, I mean, these are in the labs. There are a lot of stuff going on about this. A lot of labs researching on this. People are even researching about brain-to-brain communication, telepathy. There's a group in Duke University, Miguel Nicolas's. He's very famous, and his group is working on rats at the moment, and they've been quite successful in it. And the many applications, but the main applications currently are medical applications, like for people who are locked in, can't move any of their body, any of their muscles, and so for them, having these, they're able to control, say, prosthetic arms or wheelchairs just using their thoughts. And other applications include, so I'll be working next year for my PhD. I'll be starting to work on this. So right now I've talked about reading from the brain, but then you can also talk back to the brain by sending small currents through the brain. And this is called neurostimulation, and it has application in like mental disorders, treating mental disorders, and neurorehabilitation. So by using brain-computer interfaces, you can make neurostimulation more adaptive and automatic. So you just have this headset on, which acts like an automatic psychotherapist, if you want. And also, more interestingly, recently, are you all familiar with Elon Musk? I'm assuming, yeah. And so Elon Musk is like founder of SpaceX, Tesla, many famous companies, and he just made a startup called Neuralink, and their ultimate vision is to upload and download your brains, which sounds crazy, and I think it's a long way off, obviously. But the immediate vision is to for medical applications. So if Elon Musk started a company on this, then I think it's safe to assume that this is something that will come up soon in the market. Also Facebook, Mark Zuckerberg also started to work on this. They're having a brain-computer interface group now to, I don't know what exactly they're going for, but they said it's about getting something about like liking a status using your thoughts. And I'm not sure, I don't fully understand his purpose of doing this. But yeah, and yeah, I guess that's all I want to talk about.